I hope you enjoyed your long weekend, your day off. We are going to move on to our next section. So I want you to set up your nice, neat, organized notes. We are in Chapter 2, Section 4, and we are talking about inequalities now. So an inequality actually compares two expressions that are not strictly equal. So we're not using an equal sign in this section. We're actually going to use one of our inequality signs. And we've seen these before. They were all in our summer work. Our inequality signs follow less than or equal to, greater than or equal to, and we also have the option of having something not equal. And remember, we always read left to right. So if we're using our less than symbol, then our smaller number should be on the left. So 6 is less than 8, right? So be careful how you're filling these in. And as far as seeing these in real life, things that put limits or budgets, things like that, are all inequalities. So at an amusement park, if you've seen something like you must be 54 inches to ride this ride, that's an inequality where h is greater than or equal to 54, and h would be the height. So if you're 48 inches, you're not greater than 54 and you can't ride the ride. So let's look at our first example. We're going to jump right in. So read through this, read through it a second time, and then we'll get ready to solve. So we've got a budget of no more than $80. We have 10 children, and we're buying a cake for $12. So if C represents the cost of a party favor for each child, so per child, which expression can we use for the total cost of the party? And we'll call these A, B, C, and D. Hopefully you chose D because it's $10 per child. And hopefully you remember from our unit rate section that per means multiply. So 10 times child plus the $12 we spend on cake. So that's the first part, our total cost. Now we have to decide which inequality sign should we use to represent no more than. So our total cost, right, is no more than, and that would mean we have to use less than or equal to. So we're getting close here. Use our first two answers here, the total cost of the party, no more than. What is the rest of our inequality? And the last thing to fill in would be her budget. So everything that we spend on the party must be less than or equal to, we're okay spending exactly 80, but less than or equal to our $80. So let's say Nora finds party favors that are $6 each. That would mean we plug 6 in for C. Okay, so if you're following along, we replace the C and we plug in a 6. And then let's see if we can afford that. So we would do 10 times 6, which is 60, plus the $12 we spend on cake, and we get 72. So now I want you to answer, does that work? Is that inequality true? And here are your choices. And our answer is B. $76 on party favors works because 72 is in fact less than or equal to 80. So now she's shopping around. Nora finds a different party favor that's $8 each. And if she bought these, what would her new total be? So again, replace C with the cost of the favor. So 10 times 8 would be 80 plus 12. So we have $92 for our party. Does this work? And we should say no because 92 is greater than 80. Okay. And my last question about this problem is, why does an inequality represent Nora's budget calculation better than an equation? Why is that inequality sign better than an equal sign? An inequality would be better here because, as we saw, there's different prices for party favors, and she might not get it exactly equal to 80, but as long as she's spending less than that, she's still okay. If she finds a good sale, right, and she can spend just $50, that would be fine. We don't need to spend all $80. So that's why we want an inequality, because we have options. Okay. Now, we may need to, as with our equations, we might need to use the distributive property. So here's just a refresher on our distributive property. That number on the outside gets multiplied by everything inside our parentheses. And the other super important thing, stars, highlights, circles, arrows, this better be in your notes because I'm looking for it when you come to class. If you multiply or divide an inequality by a negative number, so you decide you need to divide on both sides by -3, you need to flip your inequality sign. And we will do an example of that as we go. But if you have something, for example, and hopefully you see how many stars I mean this is important for. Quick example, if we have -3x is less than 9, and you say we need to divide by -3, because you're dividing by a negative number, that inequality sign goes from less than and flips to a greater than. All right, so if you multiply or divide by a negative number, you are flipping the inequality sign. I better see how important you made this look in your notes when I check your notes next time you're in class. Okay. So our next example, we're going to talk about Sergio, and he's buying gifts for his 6 friends. They're all going to get the same gift, and he is going to get them gift wrapped for an additional charge of $2.50 each. He's spending at least $75. So think about what at least would mean, or examples of numbers that are at least 75. He's going to receive free shipping on his order. Okay. So again, we're going to take this piece by piece. G is going to be the cost of one gift. Okay. So I already chose, we're going to multiply everything by 6 because that is how many friends we're shopping for. G is the cost of a gift. And what else do we need to add to our inequality here? Reread the problem and decide what we are adding. Okay. We should have chosen $2.50 because it's $2.50 per gift. So we're adding that on to each gift. So what we have is 6 times G plus 2.5, you can put the 0, is greater than or equal to 75. So I want you to use the distributive property and write what our inequality will look like. And we should have 6G plus, and you have to multiply the 6 by the G and 6 times 250, which would get you 15. Now I want you to try to solve this, and we solve this the same way as we've been solving equations. So give it a try, and then we'll see how you did. So first we did our distributive property, and we got here. And then if you're solving this like we've been solving equations, you would subtract 15 as your first step. And then our last step is dividing by 6. So we have G is greater than 10. So to check, you use your inequality and you plug a number in, but you choose something that actually makes that inequality true. So like you pick a number that is actually greater than 10. So here I chose to check with 12. So take a minute and see if 12 works. So when you multiply this out, if you did 6 times 12 as your first step, right, you'd have 72 plus your 250 times 6, which is the 15. And if you add 72 and 15, you get 87. And 87 is, in fact, greater than or equal to 75. So greater than 10 is a good answer. All right, I want you to try and write an inequality for this problem. So read it, reread it, and try to come up with an inequality where V is the cost of one video game. All right, here's the inequality I came up with. I have 2 times V plus 4.75 is less than or equal to 100. So I have 2 on the outside because I'm buying 2 games, one for each brother, times the cost of each video game plus 2 times the cost of shipping. So let's solve it. First step is your distributive property. So 2V plus 2 times 4.75 gets you 9.5, less than or equal to 100. And then we subtract 9.5. And we should have 2V is less than or equal to 90.5. And when we divide by 2, we get V is less than or equal to 45.25. So Zachary can spend no more than $45.25 per game for his brothers. Okay, so $45 would be fine. $47 would be too much. All right, let's try one with a fraction. Okay, now we are still going to do our distributive property first. Okay, so I'm doing 9/2 times 2x plus 9/2 times 4 is less than 9. And remember, when you multiply fractions, you can always write a whole number over 1 so that you can match up your numerators and denominators. So going straight across, I have 9 times 2 times x. That gets me 18x over 2 times 1 would be 2, plus 9 times 4 is 36 over 2 is less than 9. Okay. Before I move things to other sides of my inequality, I want to clean up my fractions because 18 divided by 2 is just 9. And 36 divided by 2 is just 18. And now that looks a little less scary without the fractions, and I can solve from here. So we subtract 18 on both sides. So we have 9x is less than negative 9. And we divide by 9. So x is less than negative 1. Now our last step was not dividing by a negative number, right? We divided by a positive 9. So we did not need to flip our inequality sign. And let's try one more with some fractions and distributing. So distribute first. So I've got negative 2, and I'm going to put it over 1 times 1 over 6x plus negative 2 times 4 would be negative 8, greater than or equal to 9. I'm going to clean up my fraction. So negative 2 times 1 is negative 2. 1 times 6. And I still have my negative 8 greater than or equal to 9. So take over from here, see what you get. So I added 8 to both sides. I got 17. And to get rid of my fraction, remember we multiply by the number in the denominator. So you should have multiplied both sides by 6. And when we do that, we have negative 2x is greater than or equal to 102. And this is where the flip comes in. Get ready, because we're going to divide everything by negative 2. So your flashing red lights are going off. You're saying, we got to flip the sign because I'm dividing by a negative number. So now we've got x is less than or equal to, and when we do 102 divided by a negative number, right, we get a negative back. So this is negative 51. And the last question I want you to try for, this will kind of lead us into our follow-up section where we have variables on both sides. Read this problem and pick which inequality you think is best.